Good afternoon, ladies and gentlemen. Today I would like to present to you our paper. It is devoted to the estimation of resonance characteristics of surface plasmon polaridones for structures based on single metal layer with different morphologies. Here I would like to give you some outline of plasmonics. There are a lot of plasmonic devices which are constructed to fabricate in wide spectral region from ultraviolet up to terahertz region and or some main applications of plasmonics is for plasmonic lenses, lasers, or so-called spacers, fluorescence spectroscopy to enhance, for example, Raman signal, and biosensors. Plasmonic structures for biosensors application are known for decades and used for technologies. Um, when we talk about surface plasmons, which is the case for biosensors, uh, we gotta think about a fabrication of thin metal films. And there are some techniques to do it. It's a simple evaporation method, uh, evaporation and templates stripping method, which is characterized higher quality films in terms of grain sizes and smoother surfaces uh, in comparison with evaporated films, and single crystalline growth method to get metal films, which allows to get high quality films. I think it's obvious that ever ever methods is characterized by different effective refractive index of such films, and there are a lot of papers in which there were demonstrated uh, characteristics of plasmonic devices for operating in with different films. Our goal for this research is to demonstrate the resonance characteristics for planar structure, which allows to propagate surface plasmons. Um, the way of estimation of the resonance characteristics is based on Fano approximation formalism, which were discussed in details and demonstrated in the previous papers of some of the co-authors of the present research. Well, it's based on approximation of the attenuated total reflectance spectrum of these structures by the Fano formula. Um, this method allows to select some important for us, some important characteristics such as full width at full maximum, field enhancement, or estimation of the sensitivity by intensity, and estimate all of these characteristics directly using the optical characteristics of the films of the structure. So in the present research, the Kretschmann configuration was considered. As the prism, for prism layer, the refractive indexes of zinc selenides and glass of brand SF11 was taken, and air and water for the outer layer, air as a non-absorbing media, and water as an absorbing outer media. For the spacer layer, there were three metals that were considered. It's silver, gold, and aluminium. The sets of refractive indexes was taken for the um, different types, fabrication types, for evaporation fabricated method, template stripping, and the single crystalline growth. And simulation was carried out in the region from 500 nanometers up to 21,000 nanometers, up to middle infrared. So I would like to start with a demonstration of the resonance characteristics for silver-based structures. As we can see, upper plots are for real and imaginary parts of refractive index. Um, here we can see estimation of sensitivity by intensity and field enhancement to the right for air and water. As we can see, the increase in the sensitivity by intensity corresponds to decrease in the value of real part of refractive index, and it goes for evaporated method technique. Evaporated method here. It's for air case. Also, we see this for field enhancement. In the case of water, we can see that the values are quite similar to each other for uh, sensitivity and field enhancement. We can relate it to the increase of absorption in the water despite the air. If we go to the gold-based structure, it would be hard to notice uh, some differences. It is due to the almost the similar value of the different films, which were fabricated using three techniques. Um, so it leads to the quite the same values of the sensitivity and the field enhancement in all entire considered region for air and for water case. Um, and going to the characteristics of aluminum-based structures, they were calculated in the region from visible and a little bit UV wavelength up to near infrared. So we can see that here is increasing in the value of sensitivity and field enhancement and the near infrared wavelength. Um, in the This enhanced characteristics corresponds to the film fabricated by the evaporated method. So, as a conclusion of our study, I can say that it was demonstrated that method of fabrication can lead to the remarkable deviations in resonance characteristics in the case of non-absorbing media. Yeah, in case of non-absorbing media, in particular air, we saw that there is some increase in field enhancement, which could be useful for in fluorescence enhancement applications, and increasing in the sensitivity, which is good for application biosensors in middle infrared region. But in the case of absorbent media, in particular water, all the differences between resonance characteristics become negligible, that I can say. Results of the present study can be useful for optimization of the process of fabrication and performance of plasmonic structures. Here you can see some references that were used during study and presentation. Thank you for your attention. I will be glad to answer your questions.